In this video, we'll do a very brief review of SQL. SQL is covered in several courses in our curriculum. It's in CS 1222, which is a required course, and it's used in CS 3220, which is another required course. Some of you may even have taken the elective CS 4222. In any case, we won't spend too much time on this. We'll just review some basic syntax, do a few examples, and mostly focus on things specific to Microsoft SQL Server. SQL stands for Structured Query Language, and is the standard query language for all relational databases. This is pretty important because if you know SQL, you know how to use pretty much every relational database system, whether it's MySQL or SQL Server or Oracle or something else. That being said, each database system supports a slightly different variation of SQL, often known as a SQL dialect. The differences are usually not very significant, but if you use a new database system, it still takes a little time to learn the differences. The dialect of SQL supported by Microsoft SQL Server is officially called Transact SQL or TSQL. The example we'll use is this one. We'll have three tables. One has the information about employees, one has the information about projects, and one has the information about which employee is working on which project. Now, let's start by creating these tables. So I'll start by creating the employees table. It has ID, name, first name, last name, data, supervisor ID. Okay, so it will be something like this. Create table, employees, and the first column is ID, which is an integer, and it's a primary key, and it's an identity column, which we'll talk about in a moment. And we have first name, which is going to be an unvarchar. Again, we'll talk about that. And we'll have date hired, which should be a date field, and we'll have supervisor ID, which should be int, and it's references employees ID, something like this. Let me first write out the statements and then we'll explain some details. And the second one will be products. And this one has ID name leader ID. Okay, so ID is the same. And name is let's make it larger instead. Okay, let's make it larger. Why not? And then we have leader ID, which is int, and references employees ID. Okay, and then we have project members. We have project members, and project member will have project ID, which is int, references projects ID, and employee ID, which is an int, references employees ID, something like that. Okay, so let's add a primary key. We'll say primary key, project ID, employee ID. Okay, so let's run this and see if there's any syntax error. We'll put it here and we'll say run. Okay, misspelled references. And let me change it here as well. Okay, and let's run this. Okay, so now if we look under tables, we now have three tables: employees, projects, project members. And also notice that they are all under the DBO schema, which is a default schema for SQL Server. So that's why they are called DBO.employees, DBO project members, and so on. Okay, great. Now we have the tables, and let's look at some details. So first of all, the syntax, we say create table, we say table name, then parentheses, and inside we have a number of column names and the column types. In addition to column names and types, we can also have the so-called constraints like references here, primary key here, and primary key here. Now, speaking of constraints, here are the commonly used ones. For example, we can say a column is not null, or a column should have unique values. The primary key constraint that we use here is basically unique plus not null, and the references that we use here are called the foreign key constraints. A foreign key constraint means the values in some column must be among the values of the referenced column. For example, here, because a supervisor is also an employee, a value for supervisor ID must be among the values in the employee's ID column. If a constraint applies to only one column, we can specify it using the column constraint syntax like this and this. And if a constraint involved more than one column, like in this case, the project ID and the employee ID combine together to form the primary key, we need to specify it using the table constraint syntax, meaning that they are specified after the columns are defined. Now, for naming convention, we use plural form for table names, employees, projects, and we use singular form for column names, first name, last name, and name, for example. And SQL keywords are typically capitalized, like create table. These two conventions are common for all database systems. And then for Microsoft SQL Server, there are a couple of additional conventions. For Microsoft SQL Server, names are typically using Pascal casing, like names in C#. And if a name has special character, we can use a bracket around it, something like this. We can put bracket around it, and this would allow us to have special character inside the name. Okay, and then the important thing, data types. Regardless of the DBMS you use, they all support at least three basic categories of types: the numeric types, the string types, and the date and time types. For numeric types, SQL Server has integers and floating point numbers. Depending on the range of the integers, we can choose bit, small int, regular int, or just int and big int. We can use real or float for floating point numbers. Float, in particular, can be customized to specify the precision we want. For strings, we have char and varchar. Char of n means exactly n characters long, and the varchar of n means up to n characters long. SQL Server also has nchar and nvarchar for Unicode characters, like what we are using here. And typically, you would want to use nchar or nvarchar because they allow us to store strings in non-English languages. And for date and time, we have the date time and time, the date type and the time type, and then date and time together type if we need both date and time. SQL Server also has a datetime2 type. It's basically a datetime type added in later versions of SQL Server. Compared to datetime, it has a bigger range and a better precision. So if you want a type that has both date and time, typically you should use datetime2. So what about this identity here? Well, it's basically like auto-increment in MySQL. Most database systems give us something like this for automatically generating unique primary key values. In the case of identity, we can customize it a little bit. For example, we can say the auto-generated number should start from 1000 instead of 1, for example. In SQL, once we set a column to be an identity column, we cannot directly insert a value to it anymore. If we want to do that, we have to use a special command called set identity insert, and we have to set identity insert to on in order to explicitly set a value in that column. We'll see what this means in a moment when we do insert statements. And what we created here is called a SQL script. A SQL script typically has a .sql suffix, but inside it's just a text file with SQL statements and comments. By the way, SQL comments start with double dash like this. So this is the comment. One advantage of using SQL script is that you can execute lots of SQL statements quickly and simply by feeding it to the SQL command line tool. And sometimes when you read SQL scripts for Microsoft SQL Server, you'll see some Go commands in between some SQL statements, something like this one, and then Go, and then this one, and then Go, and something like that. Go is a command for the command line to SQL CMD. And what it does is tells the command line tool to send all the statements before the go command to the server to be executed as a batch. So, for example, if we run this in SQL command, this one will be sent to the server once it reaches the go command, and then this one, and then go command will send this one to the server, and so on. So when we use the GUI client, it doesn't really matter too much. Okay, Now let's insert some data into the tables, and for the table, for the employees table, we have um, John and Jane. Okay, so it's something like this. So we'll say insert into employees, and we cannot insert explicit value in ID, so we'll need to specify the list of columns and then the values for those columns, and that will be first name, last name, date hired, supervisor ID, and then we say values, and then we say the values. So the first one is John. There's a prefix n here. We'll talk about that in a moment. And last name is Doe, and the date hired is 2015. Let's say 110, and John, let's say, is the CEO of the company, so no supervisor. And then let's say this one is Jane, and in February, and Jane is supervised by John, something like that. Let's first run this too and see if it works. Okay, so we have inserted two rows into the employees table. If we do a very quick select star from employees, we can see that we get John and Jen here. Now, let's also insert the other ones. For project, we have Firestone and then 1 and blue and then 2. Okay, so we'll do insert into projects and name and then leader ID values. What? No, name is, what's the name? Firestone and 1, and then blue and 2, something like that. Okay, and let's insert a few more into project members. So 1, 1, and then 2, 1, then 2, 2. Okay, so insert into project members values 1, 1, and then 2, 1, 2, 2, 2, 1, and 2, 2. And okay, so great. Now coming back. Okay, the first thing is the syntax of the insert statements. There are two commonly used syntax. One is insert into table name, and then a list of columns, and then list of values for each column. The second syntax is simply insert into a table and then just values without the list of columns. If we use this syntax, it means that we must provide values for all the columns in the order they are defined in the create table statements. So if we do that, we can omit the list of columns here. Now, for the employees table and projects table, we actually cannot use this syntax because the identity column will prevent us from directly specifying a value for the ID column unless we do the set identity insert on thing, which will be a little bit tedious, but you can try it if you want. Okay, the second important thing about insert statements are the SQL literals. Literals are just like literals in other programming languages, meaning, the values for certain types. In MySQL, in Microsoft documentation, for some reason they call them constants, but it's the same thing. Now, if you look at these literals, for the most part, they look like what you would expect. Just remember a few things. First is that strings are single-quoted, not double-quoted like in Java or C#. And for Unicode strings, we put a capital N in front of the string as a prefix. I actually forgot to put the N here, but I still take it. Probably not as a Unicode string, but that's okay. For English letters, Unicode or not, they have the same encoding anyway. So strings are single-quoted, and prefix N indicates that it's a Unicode string. And one more thing worth noting is notice that date hired is a date column, and there's no date literal per se. Date values are specified as strings in a certain format. The default format is 4 digits for year, 2 digits for month, and then 2 digits for day. And then the system will take it as a date value or a date literal. Now, with the data in our tables, let's do a simple selection statement, aka a query. So here, let's say we want to find the employees whose last name are Doe. We would say something like select star from employees where last name is Doe. And if we run this, we'll have both employees, John Doe and Jane Doe, and we can change star to a list of columns. For example, we can select first name, last name, and it will give us first name, last name. It's a simple example, but it shows the basic syntax of a select statement or a SQL query. We say select, and then we specify the columns we want. If we want all of them, we say star, and then from, and then we specify one or more tables, and then we say where, and then we specify one or more conditions, and then that led us to get data out of table or tables. And this is another query example. Find the names of employees who were hired in 2015. Since we only have date hired in our table, which is a date column, we must extract year from date, and this would require a function. Here are all the functions in TSQL. If you look at the left-hand side, you can see that these functions are grouped in different categories. The function for extracting year from a date should be under the date and time category. And we look through it, we can see that it's right here, year. And Microsoft documentation, as always, is superb. And there are examples and so on here. You can see that we can simply say year and then extract the year from date or date time type. And with that, we can write the query. So it will be something like this. We'll select everyone is, well, we'll select the star from employees where year and date hired is 2015, something like that. If we run this, we'll again get both John and Jim because they are both hired in 2015. Well, just to check if it's actually doing something, if we change to 2016, it will give us an empty result, which means it's indeed working correctly. Now, let's do a join query. A so-called join is needed when we need to combine information from multiple tables. For example, the names of the employees are in the employees table, and the names of the projects are in the projects table. If we want to find the name of the employee who leads the project Blue, we need to combine the information from these two tables together, or in other words, join these tables together. There are two ways to do this type of join, equi-join or inner join. Let's try both. So this would be this, and we'll now if we look at the projects table, we see the leader ID, which give us the ID of the project leader, and then if we combine that with the employees information, we can get the name of the leader. Okay, so what we'll do is we'll do something like this. We'll say select something from projects P employees E, where P dot leader ID is E dot ID and the P dot name is Blue. So this is the query, and if we want the name of the employee, we'll get E dot first name and the E dot last name, something like that. And if we run this, we get Jindal, which is the leader of the Blue project. So this is the equi-join syntax, meaning that we just list all the tables in the from clause, and by the way, we can also give them the so-called table aliases so that we don't have to type the very long table names. And we can use table aliases here to select columns from certain table. And then we specify all the conditions in the where clause where we say the project's leader ID must match the employee's ID and the project's name is Blue. So this is known as the equi-join syntax. We can do the same query using the inner join syntax, which looks like this. It will say select the first name, last name from project P, inner join employee on P leader ID is EID, where P name is blue. So this is known as the inner join syntax. If you compare these two, you can see that they actually have the same tables, P and E, and they have same conditions. Leader ID is EID, project name is blue. It's just different syntax. In this syntax, the join conditions are specified after the on clause, and we need to explicitly using inner join to join two tables together, and any additional conditions are specified in the where clause. The result would be the same gen. And generally speaking, this one is the inner join syntax is recommended, especially when you're drawing several tables together, because if you're drawing several tables together, it's very easy to miss drawing condition, and then you end up with lots of uh, unnecessary results, which not only makes the result wrong, but also takes up server resources unnecessarily. When you use the inner join syntax, it's much harder to miss a join condition. In fact, most database management systems will enforce the on clause, so it won't let you to miss a join condition like this, and you'll avoid the problem of generating um, wrong results. So this is join, which is important, which is something that you have to know how to do. Then let's do a aggregation query, aka a group by query. So in this query, we want the name and the number of employees for each project. So if we look at the tables, we get the name of the projects from the projects table, and the number of employees working on the projects we can get that from the project members table. So the trick about writing aggregation queries is that we want to write a non-aggregated version first, and then later on add group by to it. So let's do the non-aggregated version first. So we'll do a select star from projects P inner join project members. Yeah, so something like this. Oh, as I said, it won't let you to meet the join condition, and we should have P ID is the project ID. This one. Okay, so we can see that this one gives us the names of the projects and then employees working on the project. So if we get this result, then from here to here is basically grouped by project name, and then count how many employee IDs are in each group. So the first group will have one employee ID, second group will have two employee ID. So it will be something like this. We'll say by, we'll select P name, and then we'll select count how many employee IDs are in each group. So it will be an employee ID, and we'll say group by p.name, something like that. So this tells us that Project Blue has 2 members and Firestone has 1 member. There's no column name. If we want, we can give it a column alias and say something like this. So this column will have the column name members. So this is how we do a so-called aggregation query. And if you don't like your password, this is how you can change your password. And that's it. This is a very brief review of SQL, again, because it's already covered in many other classes. If after this video you feel that you need more practice with SQL, just let me know and I can give you some additional exercises. And this is the end of this video. Thanks, and see you in the next one.